We want to be able to pick up our collectible game objects when our player game object collides with them. To do this, we need to detect our collisions between the player game object and the pickup game objects. We will need to have these collisions trigger a new behavior, and we will need to test these collisions to make sure we are picking up the correct objects. The pickup objects, the player's sphere, the ground plane, and the walls all have colliders that inform us about collisions. If we didn't test our collisions to find out which objects we've collided with, we could collect the wrong objects. We could collect the floor or the walls. As a matter of fact, if we didn't test our collisions, on the very first frame of the game, we would come in contact with the ground plane, and we would collect the ground plane, and then we would fall into the void of the scene space, and the game would essentially be over. First, we don't need our player to remain inactive, so let's tick the active checkbox and bring back our player. Next, let's select the player controller script and open it for editing. Just a note, we could edit this script regardless of whether the game object is active or not. Now that we have the script open, what code are we going to write? We could write collider, and then search the documentation using the hotkey combination. But there is a different way that we could do this as well. Let's return to Unity and look at the details of our player game object. What we are interested in here is the sphere collider component. In the header of each component on the left is the component's turn-down arrow, the icon, the enabled checkbox if it's available, and the type of the component. On the right is the context-sensitive gear gizmo, and an icon of a little book with a question mark. Now this is what we need. This is the quick link to the component reference. If we select this icon, we are taken not to the scripting reference, but to the component reference. We would read this document to find out more about how to use this component in the context of the editor. We, however, want to find out how to script to this component's class. To do this, we simply switch to scripting, and we are taken to the scripting reference for the sphere collider. We want to detect and test our collisions. For this project, we are going to use onTriggerEnter. Just imagine if we were, say, a daring plumber, and we jumped up to collect a perfect arc of coins, and bounced off the very first one as we collected it, and fell back to the ground. Not very elegant. This code will give us the ability to detect the contact between our player game object and our pickup game objects without actually creating a physical collision. The code example, however, is not exactly what we're looking for. But that's okay, we can change that. First, let's copy the code, and then let's return to our scripting application. Now that we're back in scripting, let's paste the code. As we have copied this code from a web page, let's correct the indents. In this case, I'm going to make sure the indents are tabs and that all of the tabs are correctly aligned. Next, let's look at this code. We are using the function onTriggerEnter. OnTriggerEnter will be called by Unity when our player game object first touches a trigger collider. We are given, as an argument, a reference to the trigger collider that we have touched. This is the collider called Other. This reference gives us a way to get a hold of the colliders that we touch. With this code, when we touch another trigger collider, we will destroy the game object that the trigger collider is attached to, through the reference other.gameObject. By destroying that game object, the game object, all of its components, and all of its children and their components are removed from the scene. For the sake of example in this assignment, we won't destroy the other game object, we will deactivate it. Just like we deactivated the player object when we were creating our pickup objects. First, let's remove the DestroyOtherGameObject code from the function. But let's paste it down below our script as a palette to work with. How will we deactivate our pickup objects? Well, what clues do we have? We can address the other collider's game object through other.gameObject. We can see this here in the sample code. And we want to test the other game object, and if it's a pickup object, we want to deactivate that game object. So let's look up gameObject with our hotkey combination and see what we can find. Now we have the page on gameObject. There are two important items here that we want. They are tag. Tag allows us to identify the game object by a tag value. and set active. This is how we activate or deactivate a game object. Tag allows us to identify the game object by a tag value, and we must declare our tags in the tag manager before using them. Let's copy the sample code, and yes, it's okay to use Unity's JavaScript in this case, as it's the same as the C# code, and paste it into our working palette. Now, GameObject.setActive. This is how we activate or deactivate a game object. In our case, just like the code snippet, we will call GameObject.setActive false to deactivate our pickup game objects. Let's copy this code and, returning to our script editor, paste it into our palette as well. I feel we have enough pieces to write our code. So let's write if other.gameObject.tag is the same as, and that's two equal signs, the string value of pickup, and we will have to define this tag in Unity later. Other.gameObject.setActive false. Now this code will be called every time we touch a trigger collider. We are given a reference to the collider we touch. We test its tag, and if the tag is the same as the string value pickup, we will take the other game object and we will call setActive false, which will deactivate that game object. Now, we don't need this code we've been saving anymore, and keeping it will only confuse the compiler, so we can delete it. Let's save this script and return to Unity and check for errors. The first thing we need to do is set up the tag value for the pickup objects. Select the prefab asset for the pickup object. When we look at the tag list, we don't see any tag called pickup, so we need to add one. Select Add Tag. This brings up the Tag Manager. Here we can customize tags and layers. We will turn down the Tags list and note that this list is empty. In the first empty element, in our case element 0, type pickup, and this is case sensitive and needs to be exactly the same string that we have in our script. And then type return or enter to confirm this tag. When we look back at the prefab asset, note that the asset is still untagged. By selecting Add Tag, we changed our focus from the prefab asset to the Tag Manager. And in the Tag Manager, we created our tag. Now we need to apply that tag to the prefab asset. Select the Tag drop-down again, and see how we now have Pickup in the list. Select this tag from the list, and the asset is now tagged Pickup. And, with the power of prefabs, all of the instances are now tagged Pickup as well. Now let's test our game. Save the scene and enter play mode. Okay. Our tag is set to pickup, but we are still bouncing off the pickup cubes just like we are bouncing off the walls. So let's exit play mode. Before we discuss why we are bouncing off the pickup cubes rather than picking them up, we need to have a brief discussion about Unity's physics system. I'm going to enter play mode for this discussion. Let's look at one of our cubes and our player. As an aside, we can select two or more game objects at the same time and inspect them all. We do this by holding down the Command key on the Mac or the Control key on the PC and selecting the game objects. When we select multiple game objects, note how the inspector changes to show the common components and property values of the selected game objects. The inspector also allows for multi-object editing. Using multi-object editing, I'm going to disable the mesh renderer on both the player sphere and the selected cube with a single click. This leaves us with the two green outlines of the collider volumes for these two objects. How do collisions work in Unity's physics engine? The physics engine does not allow two collider volumes to overlap. When the physics engine detects that any two or more colliders will overlap that frame, the physics engine will look at the objects and analyze their speed and rotation and shape, and calculate a collision. One of the major factors in this calculation is whether the colliders are static or dynamic. Static colliders are usually non-moving parts of your scene, like the walls, the floor, or the fountain in the courtyard. Dynamic colliders are things that move, like the player's sphere or a car. When calculating a collision, the static geometry will not be affected by the collision, but the dynamic objects will be. In our case, the player's sphere is dynamic or moving geometry, and it is bouncing off the static geometry of the cubes, just as it bounces off the static geometry of the walls. The physics engine can, however, allow the penetration or overlap of collider volumes. When it does this, the physics engine still calculates the collider volumes and keeps track of the collider overlap. But it doesn't physically act on the overlapping objects. It doesn't cause a collision. We do this by making our colliders into triggers, or trigger colliders. When we make our colliders into a trigger or trigger collider, we can detect the contact with that trigger through the onTrigger event messages. When a collider is a trigger, you can do clever things like place a trigger in the middle of a doorway in, say, an adventure game. And when the player enters the trigger, the minimap updates and a message plays, "You have discovered this room." Or every time your player walks around that corner, spiders drop from the ceiling, because the player has walked through a trigger. For more information on onCollision and onTrigger messages, see the lessons linked below. We are using onTriggerEnter in our code rather than onCollisionEnter, so we need to change our collider volumes into trigger volumes. To do this, we must be out of play mode. Let's select the prefab asset and look at the box collider component. Here we select isTrigger, and again, the power of prefabs, all of our pickup objects are now using trigger colliders. Let's save our scene, enter play mode, and test. And as our player enters the trigger, we pick up the objects. Excellent. Let's exit play mode. Everything looks great. We only have one issue. We have made one small mistake, and this is related to how Unity optimizes its physics. As a performance optimization, Unity calculates all the volumes of all the static colliders in a scene and holds this information in a cache. This makes sense as static colliders shouldn't move, and this saves recalculating this information every frame. Where we have made our mistake is by rotating our cubes. Anytime we move, rotate, or scale a static collider, Unity will recalculate all the static colliders again and update the static collider cache. To recalculate the cache takes resources. We can move, rotate, or scale dynamic colliders as often as we want, and Unity won't recache any collider volumes. Unity expects us to move colliders. We simply need to indicate to Unity which colliders are dynamic before we move them. We do this by using the Rigidbody component. Any game object with a collider and a rigid body is considered dynamic. Any game object with a collider attached but no physics rigid body is expected to be static. Currently, our pickup game objects have a box collider, but no rigid body, so Unity is recalculating our static collider cache every frame. The solution is to add a rigid body to the pickup objects. This will move the cubes from being static colliders to being dynamic colliders. Let's save and play. And our cubes fall through the floor. Gravity pulls them down, and as they are triggers, they don't collide with the floor. Let's exit play mode. If we look at the rigid body component, we could simply disable Use Gravity, which would prevent the cubes from being pulled downwards. This is only a partial solution, however. If we did this, even though our cubes would not respond to gravity, they would still respond to physics forces. There is a better solution, and that is to select isKinematic. When we do this, we set this rigid body component to be a kinematic rigid body. A kinematic rigid body will not react to physics forces, and it can be animated and moved by its transform. This is great for everything from objects with colliders, like elevators and moving platforms, to objects with triggers, like our collectibles, that need to be animated or moved by their transform. For more information on the rigid body and isKinematic, see the lessons linked below. Let's save our scene and enter play mode to test. Now our behavior is identical and performant. So, static colliders shouldn't move, like walls and floors. Dynamic colliders can move and have a rigid body attached. Standard rigid bodies are moved using physics forces. Kinematic rigid bodies are moved using their transform. In the next assignment, we will count our collectible objects and make a simple UI to display our score and messages.